Hello and welcome to another video. In this one we're going to be talking about dynamic programming, which is a word that sounds fancy, but in reality I don't really think it's all that fancy of a topic. To me, dynamic programming just means essentially caching, but at a more drawn out definition of it, it's where you compute a problem and you can reuse the computation of some sub-problem in order to make the overall computation more efficient. I'm going to show you an example, and we're gonna write the first kind of naive, boring implementation of this function, and then we're going to improve it with dynamic programming. But anyway, let's open up a Python file. So we're going to implement a function that's I'm going to call it tribonacci. It's like Fibonacci, but it's 3 instead of 2. If you're not familiar with Fibonacci, it should make sense as we write this out. This was actually used during Advent of Code 2020. I think it was day 10? I don't know. I don't really remember. But anyway, we're going to implement a Tribonacci function, and we're going to write this function to compute the nth Tribonacci number. And so it's going to take an int and return an int. Now, Tribonacci has 3 base cases, so unlike Fibonacci, which has 2 base cases, this has 3 base cases. So we're going to say if n is 0, the first base case is 0. If n is 1, the second base case is 1. Return 1, lfn is 2, so the third base case is also 1. After that, you will return the 3 previous numbers added together. So it'll be 0, 1, 1, and then add these 3 together, you get 2, and then 2 plus 1 plus 1 will be 4, plus 7, I don't know, etc. So otherwise, after we've established these 3 base cases, we're going to recurse here, and we're going to call trib of n minus 1, and trib of n minus 2, and trib of n minus 3. And so that implements our Tribonacci function. So if we run this, we do trib of 0, we get 0, 1, 2, 3, 4, 5, and you can see that this number starts growing rather rapidly. If we do like 20, you'll see we get a much bigger number. But this is the Tribonacci function, and I'm going to put a little print in here just so we can see every time this gets called. And trib n. Let's do this again. If we call trib of 3, for instance, oh, not 30, 3, you'll see that we called trib of 3. We also called trib of 2, 1, and 0. If we call trib of 5, you'll see that we get a lot more calls. So first we get the 4, 3, 2 from these initial calls here. Then 4... I don't know where it is. Somewhere in here, these are the other recursive calls from the other, recursions of this particular function. Oh, actually, I see what happened. So 4, this one here calls 3, which calls it here, which calls 2 here, which then calls 1 and 0 from these over here. Okay, I understand how the recursion goes. But you'll notice here that we compute trib 0 a bunch of times in here. We compute trib 3 a bunch of times in here. And we know that if we have that computation, we don't need to recompute it later. This actually gets extremely bad if you try and pick a larger number here. So let's do 50, for instance. And you'll see that it just keeps computing these numbers over and over and over. I don't know if you can see it on the video, but it's really blurring past these and running, lots and lots of computation. I don't think this is ever going to complete, so I'm just going to Control-C this. And that's because it's doing a bunch of repeated work over and over and over. Now, fortunately, in Python, there's a very, very simple solution to this, in that, we know that this input, a particular n will always give you a constant output, and so you could basically build a lookup table for all of these. But Python prevents a convenient way to do this. So we're going to do import functools, and we're going to use functools.lru cache. And this allows us to cache some number of inputs. By default, I think it's 1024. I actually did a video on LRU cache, so I will link that in the description as well. But we're just going to use an unbounded cache by saying max size equals none. And you'll see now, if we run this, if I call trib 50, it's only going to compute the Tribonacci numbers from 50 to 0 because it can reuse all of those computations before. And also, if I were to ask trib50 again, you'll see it does no more computation because it already knows this is the constant answer for 50, and so it can just spit that out. Now, this is a very, very simple example of dynamic programming. Some other dynamic programming problems involve converting a problem into a grid and computing, points at a grid and reusing those as, some cases do like a diagonalization or stuff like that. But this is just like a very simple example. But this idea can be applied to a lot of different programming algorithms. But anyway, hopefully this was useful. If you have additional things you want me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.